received a phone call one day from Bobby Glenn, who had been working for Wellcome, who had been taken over by Glaxo, and Bobby had chosen, Bobby Glenn was a well-known modeller at Wellcome, and he said, look, I'm not going to take up Glaxo's offer of a job. I really don't want to move to that environment. I'm taking up another opportunity, but I've been developing this program for protein ligand docking together with the group, Peter Willett's group at the University of Sheffield. A guy called Gareth Jones was the programmer. And he said, what we need to do now is to take this forward to, it seems to work, we need to take this forward as a product. And we've got the DTI interested, Department of Trade and Industry, in forming a grouping, which would be the University of Sheffield. Glaxo would come in as the testers of this program, but we need somebody to onwardly develop it and take it to market. And the DTI are saying it's got to be a small to medium enterprise. That's exactly what you are. So there was more discussion, and I took it to Olga, and we decided, yes, this was something we would get involved in. It used a certain amount of structural information anyway, obviously, to do the docking, but it was largely a genetic algorithm program that Gareth had developed. And that's really how we got involved, just through that one simple phone call from Bobby. And Bobby then ironically came back, not ironically, but I'm glad he did, but he came back from his other opportunity, and he's now the Professor of Molecular Science Information in the Unilever Institute, not more than 100 metres from here. But I think he was quite pleased at the way that the GOLD project was then taken forward. Yeah, so GOLD is a protein ligand docking program. So you can construct your ligand, you know the types of protein active sites it's likely to bind to, and the program will produce poses for that ligand. Poses being the shape the molecule will take in a given active site. It's been onwardly developed. It has the quality of the match to the site can be reflected back to the user and so on. And GOLD has been developed so that it will can actually be used as part of high throughput screening for a number of proposed active molecules, or even libraries of molecules. So it's really fitted in very well into the production line, if you like, of a drug discovery unit. And even though we've been responsible for GOLD since the early 90s, it's still one of the two main programs that are used in drug discovery environment. So I think we've kept its development relevant, and we've kept its development going ahead to the point where, you know, the drug discovery units are very happy to maintain the purchase of GOLD and receive all our receive all our updates. The other sorts of things we diversified into were derivatives of the CSD itself. So we derived two knowledge-based libraries from the CSD. One, a library of molecular geometry, intramolecular geometry, that contains bond lengths, valence angles, and torsions. So that's a library where people can bring in a molecule and say, what's the likely torsion about this bond in this chemical environment, and just click on it and receive a distribution of what that type of bond has done conformationally in crystal structures over the years. The other derivative knowledge base that we've produced is ISOSTAR, which is a knowledge base of non-bonding interactions, and here you can dial up, say for example, a heterocyclic ring of some sort, and you can see how that heterocyclic central group interacts with other contact groups, principally hydrogen bonding units. So you can see the principle or the main intermolecular interactions that a group of that sort would adopt, or, as seen in crystal structures. And that library also contains information from the protein data bank and from computational studies. So it's a very powerful tool for examining intermolecular interactions. We've also gone a bit further than that. We developed a product called Superstar, which was based on Isostar and was a way of directly using crystal structure information to examine intermolecular interactions in protein active sites. It was a sort of, if you like, it sort of backed up and the gold results. So you could use Superstar and gold and see that they produce similar results. And the other thing we've certainly got involved in is a bit of a change. It was X-ray powder diffraction, which has now become a very powerful way of solving crystal structures, structures which are microcrystalline but won't form samples large enough for single crystal work. And that's been done in collaboration with Bill David and Ken Shankland, who are both then working at the Chiltern laboratories, although Ken has now moved to the University of Reading. And we, again, rather like gold, were responsible for onwardly developing it scientifically together with them, but bringing it to market. And as a result of that, some of our researchers then moved to actually doing some crystal structures using powder diffraction, an area that we'd not previously been into. So in terms of research mixing with this diversification, so each time we diversified, we had to research how we were going to produce the product. So there was a paper about how the product, or several papers actually, about how the product had been produced and developed. And then where we could, application papers as well, where we, or staff of the centre, used the new products in earnest, in a scientific manner. And again, to produce papers that advertised, if you like, that we had this product and it was good, and these are the sorts of scientific problems that could be addressed.